Hello students, we are learning lesson number 7, lenses. And in this lesson, before this we have studied images formed by the convex lenses or convex lens, and in that two positions we have studied. Now after this we are going to study remaining four positions. So we'll see which are that positions. So two positions we have studied. First position we have studied that object will be at infinity, then image will be at the principal focus, and that image will be the point image, and it will be real and inverted image will be there. Second position we have studied, object will be beyond the 2f1, object will be beyond 2f1. So where will be the image? So image will be there in between f2 and 2f2, and that image will be there real and inverted, real and inverted. So we are going to see what will be the next position, and next third position is there object will be. So next third position is the object at 2f1. Where will be the object? Object will be there at 2f1. So where will be the image? What will be the nature of the image? What will be the size of the image? So that one we are going to study. So first thing is there, you have to draw one straight line. You are taking that one as a principal axis. Then you have to take some distance in your compass. Draw one arc. Here will be your C1. Take another distance in your compass and then draw another arc. This one will be your lens, and here will be your C2, and you have to join these two ends of the lens, and here will be optical center O. Optical center O. Now we are knowing between optical center and center of curvature there will be principal focus f1, and this distance and this distance is same, so you are taking here 2f1. After that, this optical center and center of curvature, they are exactly at midpoint, there will be f2. This OF2 and f2 C2, this distance will be, now this one and this one is same, so total distance will be there 2f2. Now we have to see where will be the object, where will be the image, and what will be the size, what will be the nature of the image. So where you have to keep the object? Object will be at 2f1. Object will be at 2f1. Then first light ray going parallel to the principal axis. According to first rule, that light ray passes through the principal focus after refraction. So after refraction it will go through the principal focus. And all these rays you have to draw with scale. Here scale you will place, and like this red line. Then after that you have to keep scale and you have to draw the diagram with the help of a scale and pencil. Next thing is the another light ray passing through the optical center. So we are knowing if a light ray is passing through the optical center, then what is happening? According to third rule, if incident light ray is passing through the optical center, then it goes without deviation, without changing its direction. So refracted light ray is not changing its direction. So like this way they will meet just below 2f2. They will meet at 2f2, and where these two light rays are meeting at single point, there will be image will be formed. So suppose A and B. AB is the object, and here A dash and B dash will be the image. This one will be the object here. Object will be at 2f1. Image will be at 2f2. Image will be at 2f2, and this one is their lens. So you have to draw a diagram. These are the diagrams, very simple, and if you are remembering that rules for drawing the ray diagram, that 3 rules you are studying, then it will be very easy to understand and very easy to draw the diagram, ray diagram. So 3 points we are going to write. First one, position of image. Position of image. Now where will be the image? Position of image is there at 2f2. B point is there. What is the size of the image? Size of the image. Size will be same as that of the object. Same as that of the object. That means it will be equal to object. C point is there. What will be the nature of the image? What will be the nature of the image? And that nature will be there. Nature of image. Nature of image will be there. Real and inverted. Real and inverted. So this one is position number 3. Now we are going to study diagram. We are going to draw the diagram for the position 4th one, and that object will be there now. Now in the 3rd position, object is there at 2f1. Now object in the 4th position will be there between 2f1 and f1. So 4th position is there. Object at or between, object between f1 and 2f1, f1 and 2f1. So what you have to do, first you have to draw the straight line. It will be your principal axis. Then you take some distance in your compass, draw one arc. Here will be your C1. Take another distance in the compass and then draw another arc and join these two points. Then here will be your optical center, and from where you are drawing the arc, there will be your C2. But we are knowing focus will be there exact midpoint of C1 and O. That means here will be there F1. This distance and this distance, F1O and F1 C1, these distances are equal. So you are taking total distance will be there 2F1. Here also principal focus will be there F2, and this distance and this distance is equal. So here you are taking 2F2. Now where is the object between F1 and 2F1? So you have to keep the object. Suppose this line is determining the object. Suppose this AB is object. AB is the object. So first light ray going from the B and it is parallel to the principal axis. Then according to first rule, that light ray will pass through the principal focus. That light ray will pass through the principal focus. Another light ray passing through. Another light ray passing through the optical center. You have to use pencil, then it will come straight. So somewhere they will meet here, and here will be there A dash will be there, and here B dash will be there. So they will meet beyond 2F2. Where will be the position of the position of the image? It will be beyond 2F2, and nature size will be there larger than the object. Size will be larger than the object, and nature will be there real and inverted. So here rays you have to draw, and they will meet somewhere here. So first thing is there, suppose A point is there, position of image. So where will be the image? Position of image is there beyond 2F2. Beyond 2F2. After 2F2, that image will be produced. Second one is there size of image. what will be the size? It is larger than the object, larger than the object, larger than the object. Then our next one is there C position or C point is there. In that, what will be the nature of image, and that nature will be there real and inverted. So real, where when you are saying when refracted light rays are meeting at single point, then it will be real image, and inverted, it is forming below to the principal axis, that means upside down. So this one is the fourth position. Now we are going to take fifth position. So these two ray diagrams you have to draw in your notebook, and for drawing the ray diagram you have to use compass, pencil and scale. So fifth position we are going to study, and that fifth position is object will be at F1. Object, where will be the object? Object will be at F1. F1 means first principal focus. And where will be the image produced? That one we are going to study. So fifth position is there, object will be there at F1, first principal focus. So fifth point is there, object at F1. Now what you have to do, you have to draw one straight line. It will be your principal axis. It will be the principal axis. After that you have to take certain distance in your compass and draw one arc. Here will be your C1. Take another side and draw one arc like this way, taking some distance, and here will be there your C2 will be there. Now you have to join these two ends, and where they are meeting to the principal axis, there will be your optical center. Now distance, that means C1 and O, exactly midpoint there will be F1, and F1, this distance and this distance is equal, so here you are taking 2F1. Here also exactly midpoint between O and C2, there will be F2, and this distance and this distance is equal, so you are taking here 2F2. So this one basically you should understand, and then you have to keep the object at F1. Suppose your object will be there, A, B is the object. So first light ray going parallel to the principal axis. After refraction it is going, or it is passing through the principal focus. So another light ray, it is passing through. It is going through the optical center. It is going through the optical center. So what will happen now? So when object will be there at F1, image will be produced at infinity. That light rays will meet at single point, but they will meet at infinity. So position of the image will be there at infinity. So they will meet, but they will meet at infinity, at a maximum distance. So you have to remember here, position of the object is there at F1. Position of image will be there at infinity. Light rays will meet at infinity. Then size of the image will be there very large. Size of the image will be there very large, or highly magnified, you can say. Magnified or very large. Then nature will be there real and inverted. Nature will be there real and inverted. So that 3 points: position of image, where image will be produced. So position of image there at infinity. Second point is there B1, size of the image. size of the image. So what will be the size of image? It will be very large, larger than object, you can say. And C point is their nature of image. C point will be their nature of image. So what is the nature? Nature will be real and inverted. Nature will be real and inverted. So these 3 points you have to remember each time: position of the object, position of the image, size of the image, and nature of the image. So if you are remembering these points, any time or whenever it will be asked in the exam, you can draw the ray diagram very simply. So next, last position we are going to study, and that object will be there now between F1 and O. Next 6 position object will be there between F1 and O. So we'll see how is the ray diagram. So for drawing the ray diagram, you have to use rules. So 6th position is the object between F1 and O. First, principal focus and optical center. So what you have to do, you have to draw one straight line. It will be your principal axis. Then after that, you have to take certain distance in your compass and draw one arc. Here will be your C1. Then from another side, take certain distance and draw another arc. Here will be your C2, and you have to join these two ends. Here will be your optical center, and here between C1 and O there will be F1 at exactly midpoint. So this distance and this distance is same, so you are taking 2F1 here, and here also it will be F2. This distance and this distance is same, so you are taking 2F2. So F1 2F1, F2 2F2. So now where you have to keep the object? We have to keep the object between F1 and O. So you will take object here like this way. Suppose here A, B is the object. First light ray going parallel to the principal axis. You have to use scale for drawing the ray diagram and pencil. So first, according to first rule, light ray which is coming parallel to the principal axis, then after refraction it will pass through the principal focus. So another light ray, it is passing through, another light ray passing through the optical center. Another light ray passing through the optical center. It is not changing direction, it will go straight. But here these light rays are not meeting at single point, but if you will extend these light rays in backward direction, if you are extending these light rays in backward direction, then they will meet at single point. When you will extend these two light rays backward direction, they will meet at single point. And here will be image. The image. So you can take here A dash, and here you can take B dash. So 6th position is most important because here little change is there. So in this, when you are keeping object between F1 and O, first light ray going parallel to the principal axis, after refraction it will pass through the principal focus. Second light ray, it is passing through the optical center, it is not changing direction, it will go straight. And if you will extend these two light rays backward direction, they will meet at single point, extended. So here will be the image, and here his object is there. This one is there, object, and A dash B dash is there, image. So 3 points. First one, position of image. What will be the position of image? So position of image is there. Image will be there towards the same side of the object. Image will be there towards the same side, towards the same side of the object. Image will be there towards the same side of the object. Second one is there, size will be there. Size of image, it will be magnified or very very large. C1 is there, nature of image, and in that nature of image, nature will be there. Now here different change is there, and that one is there, virtual and erect. So nature of image is there, virtual and erect. So why we are saying virtual? Because if refracted light rays are meeting at single point, refracted light ray are meeting at single point, then that image will be the real image. And if refracted light rays are not meeting at single point, but extended light rays are meeting at single point, then you are saying this image is there virtual. And erect, that means it is formed above the principal axis. So sixth position you have to remember, image will be there virtual and erect. So these points you have to write, and you have to carefully, while drawing the ray diagrams, we use scale, and this one will go like this way also. If you are using scale properly, then it will go like this way. It will meet here somewhere. Wait 1 minute. Okay, where they will meet, there will be our image. So this sixth position you have to remember. And one table is there, that table is also very easy. If you are understanding the ray diagram, that table you can draw, and objective marks you will not lose. So that table will draw, and after that we are going to study images formed by the concave lens. So what is that table? If you will do practice of the ray diagrams, you can remember that table very easily. So we'll draw that table. So in that first one is there here, position of object. Here will be there position of image. Here will be there size of image, and here will be the nature of image. So you can draw table like this way. Now this table we are drawing for images formed by the convex lens. So first position is there, object at infinity. Object will be there at infinity. Then first ray diagram you have to remember, and in that, where will be the position of image? At principal focus, F1. Size of the image is there, point image is there. Nature will be there, real and inverted. So second position will take. The next one is there, object will be there beyond, object beyond 2F1. So position of the image, position of image will be there between position of image will be there between position of image in the first case. Position of image will be there at f2. By mistake I wrote here f1, but it will be at f2. And if object is there beyond to f1, then position of image will be there between f2 and 2f2. Size of the image is there smaller than object, or smaller you can take, small also you can take. And nature will be there real and inverted. Then third point is there, third position is there object, position of object. Object will be there at 2f1, at 2f1. So image will be there, image will be also at 2f2 will be there, image will be there at 2f2, image will be at 2f2. And size of the image will be there same as object. And nature will be there same, real and inverted, real and inverted. Then fourth position we are going to study. Fourth position, already we have drawn the ray diagrams. So object will be there between, object will be there between 2f1 and f1. So image will be there. Where will be the image? Image will be, object is there at 2f1 and f1. Then image will be there beyond 2f1, sorry 2f2, beyond 2f2, that side. And size of the image is there larger than object, larger than object. Image will be there, nature will be there real and inverted, real and inverted. Fifth position is there, object will be there at f1, object will be there at f1, object will be there at f1. And image will be there, image will be at infinity. And size will be there very large, or larger than the object. And nature will be there real and inverted. Then sixth position we have studied. What is the sixth position? Object will be there, object between f1 and O. Then where will be the image? Image will be there towards same side of the object, toward the same side of the object. And image will be the size will be there magnified, or very large. And nature is here only changing, and that one is there virtual and erect, virtual and erect. So these six positions. And in the what you can say, in the exam only they are giving position of the object, you have to write all these things. So you have to do practice of that particular diagrams again and again. So after this we are going to study about next point, and that next point is there images formed by the convex lenses. Images formed by the convex lens. So what are the images formed by the convex lens? How these are there, that one will see. So this table also you have to copy. So images, or images formed by the concave lens, convex lens we have studied. Now 6 positions. So images formed by concave lens or concave lenses. Next point is the